to the 58th Annual ISNA Convention. Reimagine and rebuild with renewed resolve.
Assalamu alaikum. Welcome to AMSET session at the 58th ISNA Convention. Before I introduce the speakers, I'd like to say a few words about AMSET and its mission and activities. So I'd like to share a little presentation file and then go over that a little bit. So AMSET stands for Association of Muslim Scientists, Engineers, and Technology Professionals. It was established in 1969. It has been over 50 years now in existence. So it is a registered, currently as of now, it is registered as non-profit organization in Indiana. And we do have a few social media accounts, including Google Groups, Facebook, LinkedIn, Twitter. Membership information can be obtained at our website, amsetweb.net. So AMSET, basically, our main objective is to promote science and technology among Muslim population in the US and North America. And also provide guidance and assistance to AMSET professionals as well as students in their education and careers for networking opportunities, as well as improve the distribution and dissemination of technical knowledge. So AMSET current executive committee consists of 4 members. And that is myself, Sohail Anwar, is the president, current president. Immediate past president is Dr. Afan Badr. And vice president is Tahir Saif, secretary Rashid Rabbi, treasurer Asad Muhammad, and advisor is Saad Masroor Shah. And the web page is maintained by Rashid Rabbi, and carriers session and fair are organized by Asad Muhammad. So I'd like to continue on a little bit on our purposes, and this our activities include this ISNA session at the convention, and we bring normal scholars who are also scholars in both technical side as well as Islam. And they can shed lights on some of the technological aspects and what the Islamic perspective on that. Particularly some of the ethical issues that can arise out of new technologies such as artificial intelligence, stem cell research, and so on. Also, we advocate for public policies for responsible use of science and technology. And facilitate the activities at schools and organizations. So these are some of the things we have just talked about. Climate change is another one. Membership, anybody who is inclined for science can be a member, and it's an annual fee of $30. This is information is available on our website. So we need your support. It's a voluntary organization. We'd like AMSET to be, to expand in different states with the chapter, and also have more activities with local schools, high schools, Islamic high schools, and masajid. And with that, I would conclude. Now I'd like to introduce our two speakers. So first speaker is Professor Muhammad Al Hassan. He's going to talk about ethical aspects of AI. And our second speaker is Atif Bilal, and he's going to talk about these chat boxes, Siri, Alexa, and how the information is taken and used, and what are the ethical boundaries on that. So with that, I will stop here, and I'll give it to Professor Muhammad Al Hassan, who will take over and talk about AI ethics and so on. Thank you for your attention.
Assalamu alaikum. My name is Muhammad Al Hassan. I'm a professor of computer science at Indiana University, Purdue University, Indianapolis. The topic of my talk today is AI ethics. What and why? Let's begin. As we look around ourselves, AI technology is everywhere. Start with self-driving car. That is almost a reality. And very soon, we expect to see self-driving car roaming around our roads. Warehouse robots, that is another AI technology that has been around for quite some time. Then very recently, there is also firefighting robots, which are driven by AI technologies. Most of us are familiar with voice-enabled personal assistant like Siri, Cortana, or Alexa. AI Translator is another NLP-based method which processes natural language text from one language and translate it to another language. We also have AI-based surveillance and security systems, which can detect human or any other kind of objects and can alert a security personnel if they see a risk. And also, military drones are increasingly being driven by AI technologies. And these are just a few examples. There are many other examples, especially in the domain of agricultures and in the domain of manufacturing, and also in the domain of transportation. There are several others AI technologies that are coming into our daily life. Now, with the proliferation of AI technologies in human-facing industries, right? Ethical use of AI has become a growing concern. Especially policymakers, academic and industries, all stakeholders are now really thinking of AI ethics more closely. Their objective is to mitigate these concerns. However, we are still at the infancy at this effort. A lot more work needs to be done. And that these efforts should be centered around bringing the ethical use of AI as the forefront of our research and discussion, so that we can build AI systems that are acceptable by the wider population base without any reservations. So let's talk a little more what exactly we mean by ethical use of AI. Now, ethical use of AI mostly deal with when we are using any AI technology, what kind of concerns are there, and what would be the ethical use of an AI technology. Earlier decades, there were talk about ethical use of machines, and ethical use of AI technology is just a progression from there. Now, ethical concerns that are there on the AI technologies, I'll break them down into multiple categories. Let's first talk about the ethical concern that is coming from the technical aspect of the AI technologies. What I mean by that, for instance, given an AI systems which makes independent decisions, the question is, are the artificial intelligence systems that we are building, are they trustworthy? And are they free from biases? These biases could be, say, bias, gender bias, it could be racial bias, or it could be any other kind of bias which are in general objectionable in our current society. Second concern that someone may have, that the decision that are being made by an artificial intelligence agent, is it consistent and repeatable? If we consider different time and space, and maybe under different context, the identical data, given identical data, will the AI system produce a consistent and expected output? Decisions that are taken or that are made by an artificial intelligent agent, can we explain the decision? For instance, let's say that we have an AI system that makes decision about credit or loan application. And if some application is rejected, can the AI system provide a reasonable explanation, or a satisfactory explanation rather, that explain how and why that decision has been made? This is a very important concern. Finally, AI systems are mostly driven by software. Well, like any software, they may have bug. They may have some mistakes, or even worse, they may have vulnerability which is exploited by some third party or someone with a malicious intent. Question is, are those AI systems have sufficient safeguard installed within them so that they are free from adversarial attack or manipulation? These are some of the prime concerns that are usually covered in AI ethics, and I call them technical concerns, or AI ethics concerning technical aspect of any AI systems. Let me talk a little more on each of these points that I have covered in this slide. The most active research that is going on among those 4 points that was discussed in the earlier slide are bias. There are actually quite a bit of conferences where biases in AI are being discussed, and a lot of works going on to study how biases creep in an AI system. Well, especially most of the successful AI technology that we see today are based on supervised learning or reinforcement learning. In both supervised and reinforcement learning, we are given a collection of training data, and which in those training data, we may have a set of input and the associated output. Okay. Sometimes the output could be simple yes, no, or it could be some numbers, but inputs is typically vectors in the real space of some d-dimensional vectors. And the objective of an AI system is typically to take those input and try to learn a function f so that that function can take an input and produce the output. This is what we call supervised learning. In case of reinforcement learning, we are only given input and there is no explicit output given. However, the environment provides what we call positive or negative feedback in terms of rewards or penalty. If the action of an AI agent is considered favorable, then that is denoted through some form of reward. And if the action of the agent is considered to be not favorable, then some penalty is imposed. Okay, this kind of a learning paradigm is what we call reinforcement learning paradigm. Majority of the progress that happened in the AI over the last 10 years has been mostly in these two fronts. Besides these two fronts, we also have unsupervised learning, which is typically still is an active area of research, especially in the AI domain. Now, systems that uses supervised learning or reinforcement learning are particularly susceptible to produce AI systems that are biased or that makes biased decision. The reason for that is because if the bias is there in the training data or the implicit feedback, then those bias will be embedded in the AI system. Let me give a simple example. Let's consider that I am building an AI system which takes video data for surveillance. Okay, that video data basically detect human. Not only that, beyond that, it also detect the particular movements of the human, like how they walk, how they are maybe looking around. From that, it makes a decision whether the activity of that person is suspicious or not. Okay. Now, if we use a AI model for this problem, we need some kind of training data where we will have video data which are tagged with suspicious and not suspicious, right? Now, let's say that I collect a video library and tag those data, but inadvertently, what I have in that data, that people of certain race are, when the video show people of certain race, then those videos are tagged more as suspicious. That's it. Now, if this is something, how we tag the data, then if we allow an AI system to use the data for training, unintentionally, AI system may consider that, well, there is a high correlation with the race or skin color of a person to being suspicious or not. So in that way, the system will be biased. In future, after training, if we give a video with a certain race or skin color, and if that matched with our training data, even if the activity of that person may not be that suspicious, the AI system will predict that as suspicious. And now we can ask this question that while supervised learning or reinforcement learning has been there for years, so why are we talking about biases in supervised learning now? Why this question has not been arise earlier? One of the main reasons for that is that in recent years, we are using deep neural networks, and this has been very widespread. One of the particular aspect of deep neural network is that in deep neural network, we more often simply feed raw data. And within the deep neural network, through a lot of nonlinear transformation, the network automatically learns the features that are important to make the predictions. That means in earlier models, like in earlier supervised learning model could be k-nearest neighbor, support vector machine, or any other like that. We don't allow the model to learn features. I mean, what we make the features of the data ourselves, what we call human-generated features, and then the task of model were simply to learn the input to output function. That's it. Whereas in deep neural networks, many times raw data is simply fed in to the network, and network itself has the ability to determine what is important feature and what is not. And by doing so, the example that I gave earlier, right? A deep neural network may think, well, as I see that if, I mean, obviously the kind of actions that a person is performing gives a clue that whether he's suspicious or not. But at the same time, the AI system may also find that if the people have certain skin color, or they look in some specific way, then that is also very important to determine that whether this person is suspicious or not. And this is only because we choose the training data that inherently had this bias, and that bias is now embedded in the AI application, right? Another problem of deep neural network is that, as I said, the deep neural network generally uses large training data, because since humans are not generating or hand coding the feature, and they're just putting the data in the system, so it is very easy to sometimes generate large training data for which tracking data collection protocol or history of the data, which sometimes is called data provenance, and maintaining the desired data distribution is become very difficult. So bias prevention becomes a challenge, right? So there are actually quite a few examples in real life. In recent years, we have seen how the bias in AI system make some poor decision. One of the examples that was reported was Amazon AI recruiting tool. It was found that the Amazon AI recruiting tool show bias against women. So investigation showed that it was trained by resumes that were submitted to Amazon for over the 10-year period. And over this period, successful candidates were mostly men, and which is not surprising, is simply a reflection of the male dominance across the tech industry. So the AI recruiting tool, when it was trained on that data, the model has identified that if the phrase that contain women or any word like women are there in the resume, this is probably a poor resume, or this is, and it start penalizing such resume. So in this way, AI recruiting tool was not rating candidates, women candidates specifically, for the software developer jobs or other technical posts. So they were not gender neutral. In fact, apparently positive keywords. For example, some women, maybe she is a chess club captain. So resume may contain the word like women's chess club captain, but the word women is there. So AI systems already use that to perform a biased decision, which is basically biased against women. There are other examples. There are millions of Black people has been shown affected by racial bias in machine learning systems, which are used in several hospitals in a healthcare algorithm. So in this reporting, it is shown that hospitals use some kind of risk score that identifies that how sick a patient is and whether that patient need any personalized healthcare or needs to be referred to a program that would provide more personalized healthcare. Now, in this case, it was found by researcher in UC Berkeley that people who self-identified as Black were assigned a lower risk score than equally sick white people. Now, after investigation, what they found is that AI system was using a feature which is called healthcare cost, which is accrued in 1 year. And they found that, okay, average white person has similar overall healthcare cost to an average Black person. So apparently there was no racial bias there. So uses of this number for computing the risk score seem to be reasonable. But more in-depth study showed that average Black person is actually more sicker than average white person. So what is happening here is that by assigning similar score based on the healthcare cost or average healthcare cost, they are actually assigning identical score where the Black person is much more sicker than the white person. And given identical score, that Black person who is more deserving to be referred to the more personalized healthcare option were now ignored. So this was, again, just an example where data can be very misleading and poor training data can lead to racial bias. The last example is very interesting. This one was about gender classification. So basically, you give an image of a person and the model will tell you whether that person is a male or female. And this is just one classification task, but you can think of similar classification tasks. Maybe it can be used by law enforcement agency, maybe giving a picture of a person, identify whether that person looks like another criminals or not. So there can be many variations of this task, but let's just concentrate on this task. So in this case, the task is simply from image. We are doing a classification, binary classification, whether that person shown in the image is a male or female. So there are several commercial software built for solving this task by all the tech giants like Amazon, Google, IBM, Microsoft, and some of the popular Chinese companies. So the researchers of MIT and Microsoft Research, they actually looked at 3 of those commercial software, right? One from IBM, one from Microsoft, and another is called Face++, which is from a Chinese company. And they find that the softwares perform poorly to recognize darker skinned and female person. So basically all classifiers perform better on male faces than female face. Basically there is a 8.1% to 20.6% difference in error rate, where male faces are classified at higher accuracy. On the other hand, female faces are classified as lower accuracy. Another interesting fact was that all classifiers perform better on lighter faces than darker face. That means a black person, if the face show a black person, gender classification of that person would be in general 11.8 to 19.2% difference would be there in terms of error rate. In absolute number, error rate is highest for a dark-skinned female. It was 34.7%. That means nearly 1/3 of the dark-skinned female whose gender will be misclassified. And it was lowest for lighter skinned males. It was only 0.8%. In fact, there are some prominent female faces. For example, Michelle Obama. If you look at a more younger Michelle Obama, her picture, it was classified as a young man wearing a black shirt, right, with a confidence of 0.8, right? And that is obviously wrong. Even a popular figure like Oprah Winfrey, she also classified as appears to be male. This is from Amazon systems. And these are all commercial systems. And as you can see that these findings cause a huge uproar, in fact, naturally. And after that, Amazon and IBM and other companies have decided not to let their face recognition or face softwares to be used by any law enforcing agencies. So that made a big news. Now, again, why this happened? I mean, this is happening because you have a training data set which is highly biased or highly rich in terms of male and possibly lighter skinned persons. And so there is not enough sample in the training data for the dark skinned female. So model could not learn those examples very well. Now, what would be the remedy to bias? So first of all, we need to choose training data very carefully and judiciously. Second is we need to perform a thorough error analysis to check how the model performs on different subpopulation. So this is important, right? A model may perform very well on one population or one subpopulation, but it is very important to check model's performance on different subpopulation. And finally, we need to use explainable AI model, which will clearly highlight the justification behind a prediction or a decision. That means explainable AI is one of the most important aspects, and this is something I'm going to discuss in subsequent slide. The second point that I like to ponder on is what I call a trustworthiness of a system. I mean, all these news, that negative news that I just talked about in a few slides earlier, has impact on how people or common people perceive an AI system. So as AI system is making inroads in decision making in very sensitive domains, actually, some credit decisions, hiring decisions. It has been also noted that AI systems are being used to determine prison sentence recommendation. In all these cases, mistakes has a catastrophic effect on someone's future, right? And if we really want to deploy an AI system for making this kind of sensitive decisions, they need to be very trustworthy. In fact, the people need to trust the AI systems. There are two key questions here: that what characteristics that an AI system must process, which will make it trustworthy, first. And second is, what kind of information about the AI system that system builder or should reveal to public, so that people can trust that the AI system is producing a reasonable outcome. So here is somewhat researcher has summarized that building a trustworthy AI systems have the following steps. The very first step is that we need to know what trust is. So trust is a human trait, right? So AI system, we need to build AI system so that we can actively train the system to instill human-centered value and concept of fairness. Because human-centered values and fairness, if we somehow can define them and we can instill them in the AI system, then people can relate to these systems more easily. They can connect to the systems. And once they can connect to the systems, the trust will automatically build. And also the training and decision-making process of these systems has to be transparent. This is again going back to the concept of explainable AI or transparent AI. That means we need to provide detailed information about the training data, how the data was collected, what was the history of the data, and also include transparent and explainable justification about the decision that is being made. And the system, finally, the system has to be robust, repeatable, and safe for humankind. The accountability of an action taken by the AI system has also needs to be considered. So if we look at the points, as you can see on the right, we have human-centered value and fairness, then that is at the training time. As we do the training and we report a result, we need to make sure that the results are transparent and explainable. And as we maintain an AI system, we need to make sure that the system is robust, secure, and safe. And we need to also build what we call accountability. AI system can make mistakes. So if it makes mistakes, whose fault is that? This is something that also needs to be well studied, and it needs to be properly documented. And finally, over time, data may change. So we need to have a precise way to sustain and develop the system over time, and maybe consider where it being used and which time or era it is being used. I talked quite a bit about explainable AI already. So explainable AI is a very active area of research now in the artificial intelligence domain. In a short, what do we mean by explainable AI? It is mean collection of tools and frameworks within the machine learning domain that will provide simple explanation and justification of, for example, which input feature mostly influenced a prediction decision. If I say that someone's loan application is rejected, what was the feature that played the most important role in that rejection? Was it his income? Was it the fact that he does not own a house? Or was it his age? Or may it be possible that it was actually the zip code where he lives in? So if those input features, if we can know which features had the most influence, then we can explain it better. Not only that, by doing that, we can also make sure that the environment that is the model that is being built are bias free. And we can also check that whether the model is using some feature it should not be using. Okay. And other things that can be done is that also explainable AI can show that how the value of a feature affects a decision. For instance, if we figure out that, okay, income of a person is one of the important feature for deciding whether a credit application will be accepted or rejected. Well, so in that case, we need to know that if I keep on increasing the features, at what threshold a reject application become accept, right? So this is what we say, that how the feature value affects a decision, how a decision can be altered with a minimal change of the feature values, which basically means that we need to see all those, what we call the, how do you call these, mostly very marginal cases, because this marginal cases always becomes something like hot contested cases, right? So it may be said yes, it may be go to no. So all those marginal cases has to be very carefully checked. Finally, a lot of visualization helps. If we can do a lot of visualization of the model components and feature distribution, that also provide a generous explanation of the AI system that is being used. So if we can build explainable AI, the major benefit is obviously it can bring trust, and AI system becomes most trustworthy. Also, a lot of other issues like bias, different kind of biases, which was unintentional. But by doing explainable AI, those unintentional bias can be avoided and possibly be corrected by choosing a right data set. So in earlier slides, I discussed AI ethics that are related to the technological aspect of an AI system, but AI ethics definitely goes beyond that AI technology. One of the major ethical discussion related to AI actually on what happens if an AI system fail, leading to wrong, catastrophic, or even tragic outcome. This will be particularly true, for example, for autonomous driving, and also maybe for medical decision making, where a wrong decision can have very high cost. Now, there is a lot of discussion needs to be centered. Who should we blame if some wrong or catastrophic event happens? Because an AI system is not only a software, it's a combination of hardware, software, sensors. So it could be many things. It could be a hardware malfunction, it could be a software bug, it could be a sensor malfunction, or it could be simply a performance or latency issue, or a very unusual environment, right? So who is to blame? So this issue needs to be addressed before any AI system can be applied in this kind of critical scenarios. Another policy-related issue that needs to be discussed is whether AI systems should be deployed in wherever possible. Because whenever we are deploying an AI system, in many cases, it is replacing a human. And that can lead to mass unemployment. This is particularly true for low-skill jobs, such as jobs in supermarket, gas station, or a hospitality management. These jobs with current AI technology can easily be replaced by a robot or autonomous systems. But the question is whether this is a wise thing to do, and how we can overcome the negative consequence of the fact that AI is replacing human. Should the policymakers limit the use of this technology? Or it is better to train this population for an alternative job? So these are important issues that also relates to AI ethics. Besides policy-related issue, finally, I just want to touch upon some of the issues that are more philosophical. For example, what should be the limit of the use of AI? Should we use AI-driven robots for wars and conflict? Because machines don't really have an emotional attachment to the loss of human life or property. So using them for wars or conflict, actually, by doing that, we are risking the human race, the future of human race. Another question can come, should we use AI and robots for personalized medicine? For example, by analyzing the DNA string. Again, a negative consequence of that could be healthcare and insurance company may use this kind of technology to discriminate based on genetic risk factor. So these are also important ethical questions that we should answer. Well, so I want to conclude this talk with this final slide that is questions. Sometimes people ask that, will AI agents be powerful enough to overcome human race? Right? We have seen that in many sci-fi movies like Matrix and others. But the scientists believe that answer is generally not yet. We don't know, maybe in future. Actually, researchers have shown that AI agents learn to lie when they are used in a competitive environment. So if they can learn to lie, so who knows, maybe in futures, we can see how intelligent they can become. We need to be careful. With that, I conclude my talk. Thank you.
Assalamu alaikum, everyone. I'm Atif Bilal. I work at Amazon as a language data researcher, and today I will be talking about the field of conversational AI and how natural language processing plays a key role in the development of these conversational AI systems. And we'll also touch upon some of the privacy concerns that users have while using these voice assistant devices. So with that said, without further ado, let me go ahead and share my screen so we can get started. So I hope you all can see my screen. I will put it in reading mode. Okay, so yeah, as I mentioned, we'll be talking about conversational AI using natural language processing. So we'll talk about conversational AI and then we'll talk about natural language processing. And I'm sure you all can then see the link between these two fields. And lastly, we'll touch upon privacy. Okay, so here's the some of the key topics that I'll be discussing throughout my talk. I'll start with my background, but then we'll switch to the first topic of today, conversational AI, and we'll then follow up with the architecture of a conversational AI system like Alexa, and then we'll talk about what is natural language processing, and then we'll see some of the applications of NLP. We'll then review the job market that we have for these areas, and then we'll talk about the privacy concerns. Okay, so yeah, a little bit about my background. I didn't talk much about it early on because I knew I had a slide for my background, but I won't take that long. I hope you all can read it. But I just wanted to tell you that I came here to the US to pursue my master's degree, graduated in 2017, and then I started working with Google in New York City. That was my first job out of university, and I was really lucky to get introduced to this field of NLP because I was working with search team at Google, and search is all about NLP. So that was my introduction to this area. And then I switched over to Amazon, where again, I was hired by an Alexa team. So I kept working on the same sort of things, but this time it was more conversational AI. And one of my accomplishments is that I was the lead knowledge engineer working on the launch of Alexa in Hindi. So I worked on that launch from the very start to the end, and it was launched back in 2019. So that was a successful launch, and that really is one of the high points of my career so far. Moving on to the next slide. So as I was talking about, this is the main focus of today's talk, along with NLP. But what is conversational AI, right? So these are the intelligent systems which can interact with humans in a very humanly manner. So, for example, here is a interaction that a user is having with Alexa, where a user says, "Hey, Alexa, how do I cook chicken kadai?" And I'm sure we all have done this at some point in time. But of course, we did it using search. Maybe now it's via Alexa, which is more convenient to us. And Alexa responds by saying, "Here is a recipe of chicken kadai from Sanjeev Kapoor Recipes." That is just one of the applications from where it is getting the recipe. So as you can see, conversational AI is more like an assistant that you have in office, for example, who can help you with trivial tasks, right? So you can then focus on more complicated tasks. So the purpose is to help us in our usual tasks, the tasks which don't require expertise. So for example, you want an alarm to be set for 6 a.m. in the morning. You can just talk to Alexa. You can say, "Hey, Alexa, set an alarm for me for 6 a.m. tomorrow," and it would do that, right? You don't really have to do it yourself. So you're just trying to save time on these trivial tasks. And the way it does it, the way conversational AI works is it understands user needs and through some mechanism which is NLP based, and then it responds in a very conversational manner. And that is what differentiates conversational AI from chatbot. I know this is these two terms are being used interchangeably, and I've also done that, but I think there is a slight difference in the sense that conversational AI systems are more sophisticated, whereas chatbots are more rule-driven. They are very they are created for niche categories of requests, and they cannot handle the variance in human languages. which conversational AI can handle. So definitely conversational AI is a more advanced form of chatbots. Moving on to the architecture, I think this is very interesting to sort of go through. And as you can see in the diagram, I won't get into a lot of details here because then it would be hard for people from the audience to understand the entire architecture, but I would just talk at a high level just to give you a basic understanding of how these systems work. So here what's happening is a user puts in a user request to the Alexa device. So basically via his speech, so he says something, Alexa records that conversation, Alexa sends that conversation into cloud, right? And the cloud is where all these processings happen because, of course, why cloud? Because cloud is really the way to handle these real-time systems. You know, cloud can handle failures because there are so many, like cloud is backed by so many machines. So even if one machine fails, you can roll over to the next machine. So cloud is really, it really helps in making our system fault tolerant, as well as it helps in processing of huge amount of data because it is backed by so many machines. So just a bit of background there for cloud, but again, going back to the architecture, so the user sends a request, that request gets sent to cloud, and from cloud, it goes to the ASR system. Now, what is ASR system? ASR is automatic speech recognition. So until now, your speech is in the form of audio, right? It is speech, and then it goes to automatic speech recognition system, which essentially is a machine learning model, which maps your speech to a text. So basically, it converts your audio to text, and then that text is fed back into the main system, and from there, that text is picked up by NLU system, which is natural language understanding. And its main purpose is to understand your text, is to understand your intent, right? Like if you're saying something like, hey, who won the match yesterday? So you have an intent of knowing the game result, right? So that is your intent, and we humans can understand it automatically, but for a system to understand, they have to be trained. So NLU systems are basically machine learning models that have been trained to identify requests and map them to intents. So the text goes into NLU system here, and the text goes into NLU system, and then NLU identifies the intent along with certain other data fields, which are entities. Like if you say, if you say, what is the population of India, for example, India is a country, right? And it is an entity. So this NLU system is also designed to understand the intent. You want to know the population, that is the intent, but what is the entity here? What is the country here? That also can be identified by NLU. One of the systems within NLU, which is named entity recognition, it can recognize an entity and know what you're talking about. And then that is then fed back into cloud. And basically all these information, the intent, the slots, they are then fed into, like based on what intent you identify and what are the entity values, it goes to the right handler who can handle that request. And then the code fetches the data from backend. It could be a knowledge graph, or it could be, there could be multiple systems here, but the main idea is that code would be able to then respond to your request, get the response, get the answer, and then that answer is currently in text, so that needs to be converted into a speech form, which is TTS. TTS is short form for text to speech. So it gets converted, and that's how the response is sent back to the user. So that is all about a simple architecture for how Alexa works. And I'm pretty sure it's very similar for Google Assistant devices or Siri, for example. Moving on to ASR. So I think I touched upon this during the architecture. I can quickly go through it. It's just essentially ML models that are trained to convert spoken audio into text with high accuracy. Then we see the NLU, like the natural language understanding models. And as I mentioned, they're trained to understand the spoken intent and the associated elements, like which country are you talking about, which game are you talking about, and things like that. So for example, I've written an example here. So recipe intent. Basically, what happens is when you train a model, you pass in all these different user requests to train the model that, hey, this is for recipe, this is for recipe. Recipe for pasta is recipe related. How do you make coffee? Recipe intent. But what about this last one? What do you need to make lasagna? That is not recipe. That is like ingredients intent. That is a different intent. So then like this does not get forwarded to training the model because this is a bad example. What do you need to make lasagna? And the rest three are actually like, along with millions of data points, are then used to train these models to learn recipe related request. And that's how it works behind the scene. Okay. And this is a quick introduction flow, again, very similar to how I described the architecture. So user says when is Eid, and ASR model then tries to come up with different candidates, like based on some statistical representation. It can give one hypothesis as when is Eid, the other one as when is Eid, right? It also has confidence associated with each of these candidates, and it picks up the candidate with the highest confidence. So for example, here, I'm assuming the best case scenario, it picks the right one, and then it forwards that request to NLU. NLU identifies the intent as date of event intent, where the element or the entity is Eid, which is a festival. And then it goes to the backend code to fetch the date and then respond to the user. Now, what is NLP? Quickly, just defining the Wikipedia definition here. So at the crux of it, it is the processing of natural language data, be it audio, be it text, using some computing techniques, which is, of course, nowadays possible because of the high computing power that we have available. So like we can identify or we can analyze these natural languages using computing techniques, and then we can derive insights from it. That is what NLP is, and it sits at the intersection of computer science and linguistics. So my team there are a lot of linguists, PhD, who work on my team. So it's really at the intersection of these two fields. And as you can see, AI and machine learning is sort of is the superset which contains these different areas. Moving on to some NLP terms here. Yeah, so like these are some of the terms or terminologies used in NLP, and these are really like key terminologies. So for example, token, what is token? Token is the smallest unit of a sentence or of any document that you're handling. So it could be words, it could be phrases, depending on how you define that problem. But token is basically single word. So if someone is saying look at the example here. This product is good. So this is one token, product is one token, is one token, good is one token. Moving on to the next term here, tokenization. Tokenization basically splits text or document into small parts. And it does so by using white space and punctuation. So like in this case, this product is good would be tokenized. Basically, you cannot process this entire text as one. So you need to split them into parts. So this is one token, product is one token, and then you represent these text in some number form, in vector form, and that's how you do the rest of the NLP. But I think it's really important to break down documents into these words or phrases, and that is where tokenization is done. Third term, stop words. These are words that don't really add much to the meaning of the sentence. So for example, here, the first example says, this product is good. Even if I say product good, you would know that I am referring to, or I'm praising the product. You would know that, because at the end of the day, this and is, they are not really adding or contributing much to the meaning of the sentence. So we can remove these words in order to make sure we remove the noise in the data set. And that is one of the ways we do data pre-processing for these NLP tasks. And the last term that I wanted to highlight was stemming, limitization. So these are basically terms that can be reduced to a base form. So if you have play, playing, played, plays, all these are stemming from play word, right? And if you have these different terms like play, playing, played in your document, the computer would treat each of these words differently, but you know that they all refer to the same word. So you should do this stemming or limitization to convert all these words into their base form, and then you can do your processing, just so you don't introduce any just to make sure that your computer knows that it is play that we are talking about for all these different terms. So that's about NLP terms. Moving on, applications of NLP, as we just went through. I think conversational AI is one of the biggest application of NLP. So ASR is a form of like natural language processing. NLU does natural language processing. So conversational AI is heavily dependent on NLP. Then we have a spam classifier, which Google really uses it for Gmail. It can detect whether an email is a spam or not, which is essentially a machine learning model that has already been trained to identify using some patterns. Sentiment analysis, again, a very important area or application of NLP, where you can find out whether whether there is a positive sentiment going on with regards to any event on Twitter, or there's a negative sentiment overall. So it's just used to know more about the sentiments of tweets, and not just tweets, but sentiments of any textual data. Machine translation, a very important use case. Google uses it for its Google Translate. Amazon uses it. So this sort of, again, is a machine learning system where the machine learns to translate a word in one language to another language. And as you can see with this example, NLP is really hard. Like the fisherman went to the bank. Which bank? Is it the financial bank? Of course, we can quickly think about this as bank in terms of the river, right? But it would be hard for machines to identify that. The second example, again, sort of establishes the complexity of NLP. I'm a metal fan. Like we know it's about music, but it's hard for a computer to know that. Okay, so moving on. job market, I think there are a lot of opportunities right now with major tech companies entering this scene. Of course, Amazon, Google, Apple, Facebook, Microsoft. These companies are, of course, at the forefront of these conversational AI systems. But there are other startups entering this space, and then there are these consulting firms as well, like Deloitte, KPMG, PwC. They also have pretty good projects on these conversational AI systems. And many times, if you work at Deloitte, you end up working for Google for some project, in conversational AI space or NLP space. And I've also listed some of the roles that I found, like at Amazon, we have knowledge engineer, which I was previously. Then I moved to language data researcher. We have language engineer as well. And then there are other roles out there like computational linguist, conversational AI engineer, NLP engineer, AI consultant, data scientist, AI consultant. This is a role which I found at firms like Deloitte. So like there are plenty of opportunities. If you upskill in this area, the jobs are there. So yeah, just wanted to sort of put it out there. Okay, so we are really short on time. So let me quickly move ahead. Okay. Yeah, this is interesting, right? I know many people have concerns about whether their Alexa device is always listening to them, right? And the quick answer is yes. Yes, Alexa is listening to you, but is it recording all that you are saying? No. So that is the key difference here. Alexa only starts recording your conversation when you talk to the device. So if I'm just in my home and I'm just saying, my bank account number is this, right? Alexa is only listening to see if I'm using Alexa Word or Echo Word or Computer Word or Amazon Word, because that's when it knows that the person is talking to the device, right? So think of it as like how humans interact. When we go to a friend or when we talk to our friend, we say, hey, X, what are you doing tonight? So we are taking his name to refer to him. In a similar manner, Alexa has this wake word, and not just Alexa, Google or Siri also has this wake word, which is a word that triggers the device. So if you're using these words, that's when Alexa knows you're talking to the device, and that's when it starts recording your voice and sending it to cloud. That's the moment when it records. Otherwise, it's not recording. It's just listening to you, whether you are using Alexa. And the moment you say Alexa, from there, it starts recording up to a certain point. That's also, there's a time limit, and then it stops. But yeah, so that's when the recording happens. So it's not really that much of a concern. And again, I come from this background where I work with voice data, with language data at Amazon. But let me tell you that Amazon really puts a lot of emphasis on maintaining the privacy of users. So we are always asked to not store anything on our laptop, and there are audits that happen time and again. So we really cannot do that. And also, one key point to mention is when we have to work with language data, like of course for our analysis, we work on language data, but we are not supposed to download that data on our local machine. We can only do it by spinning a cluster. So there is this virtual cluster that we have to spin up and then work on that. And then once our analysis is done, we have to kill that cluster. We have to get rid of it and discard all the data. So there's a lot of pressure on us to make sure we are not violating any sort of privacy concerns or things like that. So that's just coming from someone who works at Amazon. So I guess you should be rest assured that your data is not going anywhere that it should not. And we are really making sure that we maintain the confidentiality, or we maintain your privacy. So some of the things that you can do at your end is your device. For example, you can mute it if you're not really talking to the device, and if you're having normal conversations with members of your house, you can just mute the device, right? And when you have to talk to the device, unmute it and then talk to it and then put it back on mute. So, the onus is on us. So that's one thing. And I think with any internet-based systems, we sort of expose our information, right? Even if we are making a transaction online, we provide our bank details, or we provide our credit card numbers. Somewhere we trust the website, right? And it's very similar here. I feel like it's very similar here. And just know that the companies really care about your privacy, and they're not really sending your data anywhere else. One additional point to note there is there are so many options presented to you when you set the device, right? Like there are options to delete voice history, in which case all your data from Amazon's database would get deleted. And I've seen that myself, like there are records that says customer deleted. So it really happens. So if you delete your voice history, if you're too concerned, then we won't be storing your data. Of course, we don't want you to delete your voice history all the time, because then we won't be having any data to work with. So we want you to only delete interactions which you think is private to you. So I guess there are multiple options when you go to Alexa app on your phone. There are multiple options you can turn on to make sure your privacy is given extra importance. But yeah, at the end of the day, the ball is in your court. You can practice these best practices, like having your device on mute, and making sure that you have these options turned on. There are messages like, do you want Amazon to share your data with third party while using Alexa skills? Like, for example, you can use Uber on Alexa. You can say, hey, Alexa, open Uber. And whether or not Amazon shares your data with Uber depends on you, right? Because Amazon sends you that message saying, do you want us to send your data? If you say no, we won't send your data. So, at the end of the day, you have to make that decision. So yeah, I think that brings me to the end of my talk. Yeah. So yeah, questions. I know people will have questions. So I think you can reach out to the organizer and they can reach out to me with questions, and I'm more than happy to answer any questions that you have. So thank you for listening to my talk, and Jazakallah khair. Thank you.
Welcome to the 58th Annual ISNA Convention. Reimagine and rebuild with renewed resolve.